All right, here's Trig lecture 11, 18, 11, 19. The student will use Heron's formula to find the area of an oblique triangle, which is what we did for the last couple of days. But in this case, the height is still unknown, but we're given side angle side instead of all three sides. And remember, we need to find the perimeter. And if we're only given two sides, we need to find that other side in order to use Heron's formula, which is what I'm going to show you how to do right now. If you're not given all three sides, but you're given side angle side, just like in geometry, that's the angle in between two known sides, then you can use this following technique. Again, here's Heron's formula. We're going to plug in our perimeter, we're going to plug in our sides here, here, and here. And it doesn't have to be called A, B, and C. The sides could be called anything you want. And we're going to be plugging in half of the perimeter into those four spaces. Just like we did when we were given side, side, side. But in this case, we're going to be missing one of the sides and we'll have to find it. We have the tools already, or the tool we're going to use. So let's use Heron's formula to find the area of each triangle, round to the nearest tenth. Now I look here and I say, well, I can't find my perimeter just yet. And for Heron's formula, I need to take the perimeter and then find half of it. So what I'm going to do, I have to find the length of this side first, and in order to do that, I'm going to use the law of cosines. The law of cosines, let's pretend like this is A, B, and C real quick. It says A squared is equal to B squared plus C squared minus 2BC cosine A. Plug all that in, I'll write all that right here. A squared is equal to B squared plus C squared minus 2BC cosine A. And we call this A, the side we're looking for. These are the two sides we know. B squared plus C squared, just so happens they're the same length, but they don't have to be. Minus 2 times B times C times the cosine of 83 will give us the length of this side squared. So I'll take the square root of it, I'll know the length of this side, then I can find the area using Heron's formula, because in order to find the area using Heron's formula, I must know the perimeter. And in order to know the perimeter, I've got to know the length of all three sides. So I'm going to use our law of cosines. Here we go. And again, these don't have to be A, B, and C. That's just how I have it memorized. In this case, it would be P, Q, and R. We're going to be looking for Q, so it would be Q squared is equal to P squared plus R squared minus 2PR cosine Q. And so here we go. We're looking for Q. Is equal to 12 squared plus 12 squared. That's these two sides. Minus 2 times 12 times 12. We've already done this in the past. Cosine 83, we're just revisiting the law of cosines. Okay, hopefully I've got everything plugged in correctly. Whoops, I don't have everything plugged in correctly. That's not an 18. I don't know where that came from. 83. I'm glad I caught that. Make lots of mistakes when I'm saying one thing and writing something else. I make mistakes. I should stop doing that. Here we go. Rounding to the nearest tenth. That's what we're looking for. Well, in order to round to my final answer to the nearest tenth, I'm going to carry this out to 2 decimal places just to get a little bit more precise, and then I'll use that to round my final answer, which is the volume of the area of the triangle. I'm going to round the area to the nearest tenth. I'm going to round this to a little more precise. I'm going to round it to the second decimal, just because I'm going to have to use an approximation in my figuring, so I want to get it a little more precise. Here we go. I'll let my calculator do the walking here. If I can find my calculator. What I did with my calculator, we may never know. Oh, I just had it. You would think that since I just had it. I'll use this calculator, but I don't like it as much as mine. Clear. 12 squared. I know where all the buttons are on mine. Plus 12 squared. Minus 2 times 12 times 12 cosine 83. Enter. And I want to take the square root of that. Oops. Gave me a syntax error. Having trouble locating the buttons. $15.990 rounded to 2 places. That is the length of this side. Now I can use this to find half of my perimeter. So I'll find, remember I'm going to use this formula to find my area. I've got to know the half of the perimeter, which is S. So I'm going to add those 3 sides together, divide by 2, then I'll put that here, here, and here. And I'll put the length of the sides here, here, and here. So I'm going to find the perimeter and take half of it. S is 15.9 plus 12 plus 12. And I'll take half of that. 19.95. And all I got to do now is plug that 19.95 in here, 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 and here, and plug my sides in here, and try not to make a mistake. So here we go. The area is, probably ought to give myself a little bit more room than that since it's pretty. So we got S. I guess I should write that down for you guys. S times S minus A, that's one of the sides. S minus B, S minus C. This is what I'm going to be doing. Where S is half of the perimeter that I just found, and A, B, and C will be the length of these 3 sides. So here we go. S is half of the perimeter. 19.95 minus A, which would be any of these sides. 19.95 minus B, which is 12. 19.95 minus C, which is the other side. I just got to plug in all 3 sides into this. It doesn't matter which one comes first. And then I got to get all that into my calculator and see if I can not make a mistake. So here we go. Clear it out. Got 71.4. If I haven't made it, no, that would be 71.5. I got 71.4605, so forth and so on. So that would be 71.5 approximately. That would be inches squared, would be my area. I'm sorry you had to sit there and watch me poke all that into the calculator, but that's what it takes. That's just part of math. You have to be patient sometimes. Hey, I found my calculator. I had it underneath a piece of paper. Okay. And now I want to see if I got the answer right. Go through all that and get the wrong answer. That would be embarrassing. And I'm looking at the wrong answer sheet. That was embarrassing. 71.5 inches squared. Yay. So what did we do? We used the law of cosines to find this missing side. You can call this q squared is equal to p squared. Q squared is equal to r squared plus p squared plus minus 2rp cosine cubed if you want to. I just did this, and remember that these are the sides and that's the angle. Once we have the missing side, we find half of the perimeter, plug that in here, 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 and here, plug the sides in, as we had to find that side, plug those in there, and try not to make a mistake with our calculator. It's very easy to hit the wrong button. Well, let's see, let's do another one real quick. What the heck? Okay. I've got a missing side. So again, this is what I'm thinking. This is the one that I'm going to call this A, that's what I'm looking for, and this will be B squared and C squared. I'm ignoring these letters right here. I'm just going to plug in my sides into this and the angle that I know here, and that will give me this missing side. So here we go. Is equal to last time I wrote the wrong answer. I mean, the wrong angle there. Okay, again, I know these aren't A, B, and C, but I'm just using this as a pattern. This is one of the sides I'm looking for, so these are the other two sides, 10 and 15. Okay, and this is the angle, and that will give me the length of this side. That's how the law of cosines works. So let's see if we can get all of that into our calculator. And I found my calculator, and then I promptly lost it again. What is it with me and my calculator? There it is. There we go. Make sure it's cleared. $124.26 is what I'm going to call this. I know it's around the answer to the nearest tenth, but because I'm going to be using, oh wait a minute, I want to take the square root of that though. I almost messed up. 11.15 is what I'm going to call it. I almost messed up there. This is an approximation. I'm rounding it to 2 decimal points. I want to be a little more precise because I have to use an approximation. So I want it to be a little bit more precise so that when I finally round my final answer, which is my area that I'm looking for, I'll have a little more level of precision since I have to use an approximation. So here we go. I want to find S. Well, S is these three numbers added together divided by 2. It's the perimeter divided by 2. So let's do that real quick. It's just like we did when we were doing the other stuff, when we were getting side, side, side. For the last 2 days we've been doing that. So it's 15 plus 11.15 plus 10 equals, and I'm going to divide that by 2, equals 18.075. And I know the sides are 15, 10, and 11.15. So here we go. This will give us this is what I'm going to be doing. S times S minus A, S minus B, S minus C. S is the half of the perimeter that I just found. Hopefully I found that correctly. And then A, B, and C are the length of these sides. So I'm going to plug all that in to this form and then let my calculator do the walking. So here we go. S is 18.075 times 18.075 minus A. It doesn't matter which one I call A, I'm just going to make sure I get all three of these in here. Do these in any order. I already put in the 10, so I'll put in the 15 next. And I've got these two in already, so now I'll put this one. Okay. Now I just got to try to get that into my calculator without messing it up. So here we go. I'm going to give it a try. Got 55.7. I sure hope that's right. That's an awful lot of button pushing. If I messed it up, I'm going to be embarrassed, and I'll have to do this whole thing over again. And what's our unit of measure? Centimeters. So this would be square centimeters if I haven't made a mistake. And if I have, then I get to tape this whole lecture over again. Yeah! 55.7, I can't believe it. So what did we do? And if you make a mistake, don't beat yourself up. I mean, it's easy to make a mistake. We looked at this and we said, well, we want to use the Heron's formula to find the area of this triangle because we don't know the height. And we were missing a side. So the first thing we did was we said, hey, we can use the law of cosines here. You could try to use the law of sines, but you wouldn't be able to. So you would switch over to the law of cosines. And if you use the law of cosines, here's just the general form. And you could write it as P, Q, and R if that makes you more comfortable. We plugged in our sides and our angle right here, excuse me. And then we found the length of this side. That enables us to find S. We add these three together and divide by 2. It's half the perimeter. That's S. Once I know what S is, I can plug it into this formula. Put S here, 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 and here. Put the length of the sides here, here, and here, and it doesn't matter what order you put them in. And it should look something like this. And then we try to get all of that into our calculator without making a mistake. And I didn't. Yay. I can't believe it. And we would look for this among our choices in multiple choice. So there we are. We are using Heron's formula. We're finding the area of an oblique triangle. We don't know the height, but we do know side, angle, side. Side, angle, side. Side, angle, side. You can do this. Just take a deep breath.